Imagine there is a traffic light that does not work and drivers are having a hard time using the road. So, a policeman shows up to direct the traffic so there's no confusion. This means that drivers must now follow the directions given by the policeman. In electronics, the diode is like the policeman because just like the policeman tells the cars which direction to go, the diode also tells the current which direction it should flow in the circuit. Or, simply put, it directs current flow. There are many types of diodes with various properties. The diode is cylindrical in shape and sometimes black in color or clear like glass. It has two metal strips sticking out of the cylinder called the terminals. One terminal is positive and that's also called the anode. The other is negative, which is also known as the cathode. To identify the negative terminal or the cathode, look out for the side of the cylinder with a colored band. For instance, on the black diode, the cathode is marked with a silver colored band. Remember that the band can be in different colors on clear diodes. Since we know what the diode looks like, let's learn how it works in the circuit. The anode and cathode play a very important role in making the diode move current in only one direction, and here is how it happens. Current can flow through the diode under only two conditions, and they are: 1. The anode or positive terminal of the diode must be connected to the positive terminal of the battery, and 2. The cathode or negative terminal of the diode must be connected to the negative terminal of the battery. When these two conditions are applied, we say forward bias has occurred. So, forward bias simply means the process by which a diode allows current to pass through a circuit. On the other hand, there are also two conditions that prevent current from flowing through the circuit. 1. If the anode or positive terminal of the diode is connected to the negative terminal of the battery. And then 2. If the cathode or negative terminal of the diode is connected to the positive terminal of the battery. These two conditions are referred to as reverse bias. This means the process by which a diode does not allow current to pass through a circuit. Now, it is also important to note that the diode is the simplest semiconductor in basic electronics. A semiconductor is a material whose ability for current to flow through it is better than that of an insulator, but not as good as that of a conductor. Also, because of the two terminals, the diode can be called the p-n junction diode, P representing the positive terminal and N representing the negative terminal. Another type of diode that exists is the LED, light emitting diode. LEDs, as the name suggests, light up when connected to a complete circuit. The light indicates whether there is current flowing through or not. It lights up when there's forward bias and stays off when there's reverse bias. There are two ways to identify the positive terminal from the negative terminal in the LED. The LED also has two metal strips sticking out, but this time they are all on one side of the diode. The ways to identify the terminals are: 1. The longer strip is the positive terminal and the shorter strip is the negative terminal. And 2. When you look into the LED, the metal that looks like an upside down L is the negative and the metal that looks like an I is the positive terminal. Before we end this chapter, it is important to know why the diode allows current to flow in only one direction. The diode protects the circuit from instances where the current is flowing in reverse to the power source. Without the diode, there can be an explosion due to the reverse current. Also, the diode is very important when you are charging electronic devices. When charging, current is supposed to flow from the power source to the device and not the other way around. With the diode present, current will not flow out from the device so that when you are not charging anymore, the stored power will power up the device. So the diode basically protects the circuit.